get really done
Okay.
from
It's almost
really
like
fast execution of community, like
It's
never going to be
one through one stuff.
yeah, it's been hugely successful because
Then for
it
every
brings it
given
to people where they are.
how many
So
three-dimensional
to me, that's what it's all about. You can, yeah, you could convert it entirely it's highly performant.
So
But
that's
every
one thing that
target
makes it
you
awkward to just
what
such a
is
submergible thing. It's like, but
yeah, and so
I totally makes sense. So it really ought to be.
like we,
And what makes sense
massive
one reason why it
when we
doesn't fight
first
first
started making Dino, I think we were
So we have
like
something that works.
two performance.
Two.
You looked at the raw.
There's already this
I think we can get started. Good afternoon, everyone. So today we are going to talk about profiling concurrent search in Lucene. You might notice that my title says parallel execution, but we will mostly be talking about concurrent search. You might ask why the mix-up. So I think explaining difference between parallelism and concurrency is a NP hard problem. So a little bit about myself. My name is Ankit Jain, and I'm a software engineer with the AWS Open Search Service team, leading development efforts for search resiliency and performance. I'm also active maintainer for Search open source project, and recently nominated to be committer for Apache Lucene project. Yeah. This is my first time speaking at Apache conference, and so I'm very nervous and excited to be here. Bit more nervous because I need to talk about concurrent search with people who wrote it. So I think Mike was one of the big proponents for concurrent search in Lucene, and Atri Sharma did some work for enabling it. So truly a humbling experience to be presenting in front of such an elite crowd. How many people know about Apache Lucene here? Okay, probably everyone. How many people know about there is profiling support in Lucene? Okay, so I think we have the right crowd here. So yeah, so I think we have a packed agenda today. So we will first talk about what this query profiler is, and we'll do a very quick recap of OpenSearch and how search executes in Lucene, as if the people need that recap here. And then we'll talk about how the profiling for non-concurrent execution. We'll try to understand how that profiling looks, the output, etc. Then we'll talk about some of that will allow us to understand the challenges that are there with the concurrent execution and how we address those to enable profiling for concurrent case. And then in the end we will talk about how you guys as community we can collaborate more on the profiling work to take it forward. So what is this query profiler? So we might have heard a lot about systemic profiling tools like JFR, YourKit, Async profiler and whatnot. But the profiler that we are going to talk about today is very different from that. It is not a generic profiler tool that you can apply to any Java process or something like that. It is very specific to Lucene based search engine. Right? It is able to provide you some deep insights on the query execution plan, expensive components in the query execution, and it can also provide you visualization of that query execution time. So yeah, I think this is, I would say don't try to read that. So this is, I was working on a customer case like some 3 years back. So there was this customer, who were seeing like very high CPU utilization of their cluster, right? And they were like very big customer for AWS, and they were escalating left and right. We need to get this addressed soon, and that is when I got engaged in for that customer. I looked at some of there is a slow log feature that we have in OpenSearch, which is able to tell you like if a query takes, let's say, more than a certain threshold time, then we are able to log that query. So I was able to find that query in the log that okay, this query is taking about 60 seconds. But I was still not sure, looking at that query, it seemed a very innocent query, but it was taking 60 seconds. So I was like, what's going on? That is when I took that query, ran it with a profile option, and this is what it generated. So this is probably 1/100th of what it generated. So yeah, so essentially what the customer was doing was they were like running a search on star field, and star field is like in OpenSearch, if you run a query on star field, it will try to run the query against every field in the index. So they were trying to do a star hacker one star query against all the fields in their index. So no wonder it was like blowing up, and their CPU was spiking to 100%. And that is when I realized, how powerful this profiler tool is. So it took me like literally 5 minutes from getting the query to figuring out what exactly is going on. With this background, let's take a look at how this profiler came into being. So this was introduced in Elasticsearch 2.2 in Feb 2016. So that is when this profile API was first introduced. In Elasticsearch 5.2 version in October 2016, they added support for aggregation profiling as well. In Jain 21st, OpenSearch was forked from Elasticsearch, and in September 21, shortly after, so Jack and Julie added support for query profiling in Lucene. It is the same profiling that we had in Elasticsearch earlier. In October 23, OpenSearch added support for concurrent search profiling, and which is something I backported recently to Lucene about a month back. So a very quick overview about OpenSearch. OpenSearch is an open source Apache 2.0 licensed distributed search and analytics engine based on the Lucene search library and originally forked from Elasticsearch. It offers a scalable community-driven platform for real-time monitoring, log analytics, and website search, among other use cases. The OpenSearch core architecture is made up of clusters, nodes, indices, shards, and documents. At the top level is the OpenSearch cluster, a distributed network of nodes, each responsible for different cluster operations based on its type. Data nodes are responsible for storing indices and handling tasks like data ingestion, search, and aggregation. Each index is divided into shards, which include both primary and replica data. Shards are distributed across multiple machines, enabling horizontal scaling for improved performance and efficient use of storage. This is primarily what we need to know about. So every shard in OpenSearch is a Lucene index, which we can see is exactly like it ingests documents. The documents are ingested in memory first, which are written into in-memory segments and then flushed onto the disk eventually. Okay, this is a tough one. So I need to talk about some of the basics about search execution in Lucene, and I want to ensure that I don't get it wrong, right? In this room especially, so I'll just be reading my notes. So there is this thing called leaf reader, which each segment has its own leaf reader that provides segment specific access and operations. There is an index reader which provides access to the index files and data structures. Index searcher is something that wraps index reader and provides the search functionality and APIs. Query is just an abstract representation of what to search for, independent of any specific index, immutable to support caching. Some of the common examples are term query, boolean query, phrase query. There is a weight, which is index specific representation of a query created for a specific index reader that handles global view across all segments. There is scorer, which is a segment specific representation of query created by weight for each segment. It provides document iteration and scoring functionality, which has different implementations for different query types. So at a very high level, the query execution flow is Lucene gets a search request. It will parse the request and rewrite the query. It will create a weight from query and iterate over all the index segments, create scorer for each segment, use scorer to iterate over matching documents, and pass the matches to collector for processing. Some of the common implementations of collector we know are top score for regular searches or top field collector for field-based sorting. Okay, I think this is where we start getting into some of the interesting stuff. So let me see. So we'll do a very quick demo of this profiling functionality once I figure out how to get my screen there.
Yeah, it's now.
Yeah, but now I can't see what's going on.
You saw his terminal?
Sorry?
You see your terminal?
Not on my laptop, but yeah.
You can see it in reverse.
Yeah, I can try to mirror it, but sorry, just give me a second.
Challenges and demo.
Yeah. I was thinking whether I should just keep a recorded demo, but I was like, yeah, we should try to do it live. Okay, so I'll just start a single node OpenSearch instance over here, right? So the reason we have to use OpenSearch here is because OpenSearch has some APIs using which we can easily generate the profile output, right? So, and now we have started a local instance of single node instance of OpenSearch, which shares all the responsibilities like data or search ingestion, everything, and then we will. So this is like I'm using OpenSearch benchmark here to index like say 1,000 documents for very common workload called HTTP logs. So it should take like about 10 to 15 seconds, hopefully. Okay, so I think it should be done. Yeah. Now, one of the things we can try to do is we can run the search API with a profile option. So yeah, this is the query that we are going to run here. So it is going to search in the logs. So this is one of the index that we just created, which has some of the documents, and we will just be running it against one of the shards, shard number 4. We don't want to because for this talk we just want to talk about Lucene specific thing. So, and then this is the option that we specify in the API, which is like profile true, right? So this is for enabling the profiling, and this is what the query is. So it does some filtering on the timestamp, status code of the documents, etc. So once we run this profiling, so the response is very similar. So it will still have hits at the top, which is like just 2 documents over here, and after that it shows like how the query actually executed. So for example, at the top level we know that this is a Boolean query, right, which has a constant score query on constant score wrapper on top of this term query, and then we have this index or doc values query, and it tells you like how much time this query took, and it also gives you a breakdown of various low-level methods within Lucene. So, and it also then breaks it down into children, so that you are able to tell okay, even though overall Boolean query took this much time, how much time each of those, like if there were specific expensive paths within that Boolean query. So, and there is a very easy way to visualize this as well. So I can just take this profile output and paste it in a tool like this, and then I just say visualize, and it will be able to tell me that this is like at the top level it's a Boolean query, it took this much time, 49.1% of the time went in this, and then you can also look at the raw data, raw information that we had in the profile output. So yeah, it's a bit easier using this visualizer tool. And so this was the example that we just ran right here. So this is another example. This is a much complex query. These are the types of queries we are used to, because this is what most of our customers run in production, right? So these are like some standard business use cases. So they will have like bunch of filters and whatnot, right? And then again, we are still able to leverage the same approach. We generate a profile on top of that, and which is like much more complex here, right? So but it is still able to offer similar insights. For example, here we can see that this index or doc values query was processed as a doc values query. So which is something we cannot just take a look at the query and tell how it is going to execute actually. Okay, so I think with this background, let's switch to our extended display.
Can I ask a question?
Sure.
Does the profiling tools have support for diffing profiles? So like if you made an improvement or aggregating across multiple queries or any other kind of analysis?
Not across multiple queries. This is at a per query level.
Yeah. Because like, you know, I'm just analogizing to other kinds of profilers that I'm familiar with, right? Sampling profilers that execute, they collect many samples, right? Many things. It might be an interesting direction.
Yeah, so I think those, at least what I have found is like those are for systemic level profiling, when you want to see, okay, what my CPU is busy doing, like not for understanding how individual query is executing.
Yeah.
So yeah. This is a bit more like maybe a query planner in SQL world that is able to tell, you know, how that individual query executed.
Yeah.
Okay, so yeah, so I think we just want to we kind of skimmed over the granular metrics that are which we have as part of this profiler, but this diagram gives a good overview in the query execution. So create wait is like one of the first thing that happens when a query starts execution, right? And for each of the segment, so we can see this create wait is something which happens at the shard level, but it can happen multiple times depending on how hierarchical the query is. So during the execution, if it has like bunch of Boolean queries wrapped into one another, then it will just, you know, try to go down the tree and create wait for each of those individual queries. And then we have like build scorer, which is something which is created at the segment level, and for each of the matching docs, we can invoke this next doc or advance or these match APIs, which is again something recorded into the profile output. So it is able to tell, you know, overall how much time we ended up spending in advance API, right? And similarly for collector, which is something which kind of also runs at the segment level. So as we keep iterating over these documents, these are passed to the collector as well, and that time is also recorded into the profile output. And for each of these times, right, for example, next doc or advance, it also has the number of invocations of these API. So looking at the profile output, you can tell, okay, how many times the next doc was invoked. So, and match is something like, I think, in case like people are not familiar with match. So match is something which is used for, like this two-phase iterator is used for a phrase query, where in the first pass, you want to just identify all the documents which match all the terms in the phrase, and then there is a second phase in which you want to ensure that like they are in correct order. So now we will just spend some time understanding how we are building this profile output. How is this, how we are able to build this. So for that, we need to understand like some of the wrappers that we have in Lucene. So you might notice that they are very similar to the search classes, right? For index searcher, we have something called query profiler index searcher. For weight class, we have query profiler weight. For scorer, we have query profiler scorer. For collector, we just have profiler collector because there is no query here. It's used for aggregation mostly. And then there are like some of these profiling specific classes. So there is a query brief profiler breakdown. There is a query profiler breakdown and query profiler tree. So query profiler tree is the key profiling class which stores the all the profiling information, right? So as we go top down into the query, creating weights, it keeps adding the correlation for each of the query nodes that, okay, for example, if two clauses are within a Boolean query, then these two clauses are children of the top level Boolean query. So, and if we like just take a very quick look at how these wrapper classes look like, so they are like very thin wrappers. So what they have is, so for example, we look at the top level index searcher. So this has a profiler tree. So whenever we want to execute a search request, it will create a new profiler tree, and it extends an index searcher, so it is automatically getting all the APIs. So if you call the rewrite, it will just start the rewrite timer, and it will delegate to the superclass for doing the actual rewrite. And once the rewrite finishes, it will just stop and record that time. Similarly, if we look at the creation of the weight object, so it will do something similar. It will go to that profiler tree that we created earlier to get the profile breakdown object, right? And then it will add a create weight timer into this profiler, and eventually, so here as you can see, right, instead of returning the actual weight, it is returning a query profiler weight, which is again wrapping the underlying weight so that it can further keep tracking the cost for calling individual operations like build, scorer, and other things. So this is how it is able to generate detailed information about cost for each phase of the query. There are like, while this is very good, but unlike say tools like JFR and some other tools, we cannot keep this enabled in production because it has like significant latency overhead, right? So if your query might be taking 1 second otherwise, with this enabled it might take up to 4 or 5 seconds. So it is not the actual representation of the time taken by a query. Also these the times that are so time in nanos is something which is output by this profiler. It is not the wall clock time. It is just trying to estimate the time for that operation, right? So there might be like other things which are like not accounted for. So if it says, okay, this query took this much time, it's not necessary that the query will finish after that much time from start. And as we already saw, the response can be like really huge, right? Especially when the query can be hairy. So yeah, this is again something we have to be wary of. I think most of the people will know here, right? What is this?
What about it?
Sorry?
What about it? What's the question?
Like, what is this?
It's index searcher,
Index search,
search
index
implementation, entry point, top entry point for search.
Yeah. And so recently I think we added this keyword on top of this method. So, right, and that is when, because the life used to be very simple, we will take a query, we will just rewrite it, we will create a weight object, and then we will iterate over the segments and just search on top of that. But when we introduced concurrent search, this is what we made this method to be. So now it does like some computation. So it will like create bunch of slices, right? Then it will try to create collector. So there is this new abstraction we have introduced called collector manager, because for each of the slice we want to have a separate collector, and then we need a collector manager to reduce all those collectors into a single response. So like all of this is done for the concurrent search, right? And as we just looked at the profiling logic, right, for the sequential case, we can see that why it's very clear why it will not work in the concurrent case, because all these timers that you are trying to record, if they are shared across the whole shard, right, across whole index in Lucene. So if you are trying to invoke those concurrently, they will obviously not be correct, right? So that is when like this profiling with the concurrent search enabled, the profiling will not show the correct response, and so that is what we were just trying to see, how we can go ahead and fix that. And so when we did it in OpenSearch, right? So as I was showing the history of this query profiler earlier, so in OpenSearch we were able to use this information from the collector manager. So collector manager essentially has a list of for every collector it has a list of segments, right? So you are able to use that correlation to say, okay, which slice this segment is executing as part of. And so I was when I was trying to add this concurrent profiler in Lucene, I kind of tried to apply the same logic, and that is when I got to know about something called intra-segment search, and I'm like, wow, okay. So that assumption is no longer true, right? Because now there is new concept of partition, and so different slices can share the same segment. So I'm like, okay, now we cannot rely on this information. So and so that is where we realize, probably even though we did it in OpenSearch a couple of years back, but we can no longer rely on this information. And so when we started profiling with concurrent segment search, we introduced something new called earliest timer start time. So what this kind of indicates is, in a sequential case, when a query starts processing, right, it will the segments will keep getting picked up gradually by the same thread, and eventually it will be done. But now with this new paradigm for concurrent search, it's possible that some of the slices don't even get picked up immediately. They are just waiting in the queue for a worker to pick, right? So that is why we need this concept of when individual slices are getting started, right? They might not be picked up immediately, and that might give us very useful insights into, okay, maybe we are trying to create too many slices. We don't have that much CPU for our workload, right? And another thing we added was this query leaf profiler thread aggregator. I know it's not a great name, but I think it goes with convention of how we have names in Lucene. So at least some of them. So what this tries to do is, instead of trying to aggregate information for all the slices together, it will try to aggregate at a thread level. And the moment we start aggregating at thread level, we don't have to worry about concurrency issue, right? So with this implementation, we are able to visualize the so let's say we have 6 slices in our search request, and each thread, so there are 3 threads processing that search request, and each thread ended up processing 2 slices. Then this is how the visualization after current implementation will look like. So it will show that, okay, the processing on thread 1 for the search request started at this time, and it overall took about this much time. And thread 2 started processing at this time, and overall it took this much time. But thread 3, for example, in this example, it started a bit late, right? And this could be a critical path. So it can still help you understand, why the search request, even after enabling concurrent search, it is taking more time. Ideally, we want to get to this place, right? We want, even within a search thread, we want to be able to say, okay, this is when the slice 1 started, and this is when the slice 4 started on the same thread, right? This is when slice 2 started, and this is when slice 5 started. So, and so on. Because this gives you even more granular information about how those individual slices are processed. Although one of the disadvantage with this is generated for each query in the tree. So as you can imagine, like if there are 10 levels of query in the profiler output, then there will be 6 of these for each of those 10 levels. So yeah, I mean, this can get really hairy, but I still feel there is some value in this, or maybe we can have some sort of knob or parameter which can say, okay, I want to aggregate at this level. But currently the problem is, at least I could not find a good way of aggregating the profiler information at slice level. So that's why we currently have it only at the thread level, but this is something that we want to, I want to improve. And this is where I want to like call, since you guys now know about this interesting tool called Profiler in Lucene, right? We want to like do more work to ensure that we are able to support slice level aggregation, intra-segment use cases better. And also, as we saw, right, so this profiling is like more like a thin wrapper on the search execution flow. If there are any changes in the search execution flow, we want to ensure that we accordingly make changes in the profiler as well, so that it is able to provide information on the correct execution, right? So while it is very good, but I feel it is a constant work as our search execution flow evolves. These are like some of the notable links. So I think the first PR is the very initial contribution, and then second one is for the concurrent search, and the third is if you want to visualize this profile output. So this is the visualizer we can use.
That first PR is a prefix of the second PR.
Yeah, I just noticed.
It's incredible.
Yeah. So, yeah, good observation. So, yeah, I think that should be it.
Hi, I was looking at this and thinking, wouldn't it be cool if the query profiler tree, which you said was the entry point, if that's extensible, I could imagine hooking that up to OpenTelemetry, generating traces, because that way I can plug it into to telemetry infrastructure I already have, and I'd imagine enabling this sometime, but for some queries, but not others, based on my whatever my app is.
Yeah.
Now, in this case, is that class, is it designed to be pluggable to whatever I want to do with these entry points, or does it capture it the way it does, and I'm forced to read the result at the end and do whatever with it?
I think you're forced to read the results in the end.
Okay.
Yeah.
But I can still do what I want to do. It just means I need to manually talk to. Yeah. So it's, yeah.
By the way, one thing I was wondering when I was working on the content, do we have support for profiling in Solar, for like query level profiling?
You have a debug. You have a debug, right? Debug true.
Yes. But this is more detailed.
Yeah.
Like you have timings of the Lucene level aspects, and that is not at that level.
Yeah.
Is at the Solar level.
That could be where we put the.
Got it.
At Solar, we differentiate time spent on facets versus query versus.
Got it. Got
Solar
it.
level, right? Got it, to your point.
But not detail within. Your time spent on the query was 10 seconds. Where did that actually go? Debug Lucene.
I just wanted to bring up the idea of aggregation again, because it looks to me as if with the way you create the index searcher, the profiling index searcher, you could run multiple queries through it, right? What would happen?
No, but I think the weight underlying weight will be shared across those queries, right? So.
I mean, I see. Yeah, it would create a new query profiler tree for each query that you ran, and then I would presumably just discard the previous one or something.
Yeah.
Okay, I see.
The visualizer that you linked up there, is that tied to the OpenSearch profiler format output, or is it tied to the Lucene output?
Okay, I think that's a good question.
It's open source right now.
No, like
The visualizer that you had, the last one.
But I'm just wondering, it can just display any JSON, right? Or does it say that you know it has to be this?
Yeah, I think the logic it has is kind of more towards to process the OpenSearch profile output. So yeah.
Yeah, but I think that is something we can like quickly adapt for Lucene case as well. So
So in OpenSearch, you have a separate OpenSearcher or index searcher when someone hits profile equals true, or do you create one on the side?
yeah, so right now we have separate because the implementation was already there in OpenSearch, and but I want to make sure that it kind of refers to the implementation in Lucene, so that we don't have to maintain it at both places.
I was wondering that, like you said, there is a problem today that we cannot capture slice level information.
Yeah.
So in the index searcher, when it submits the runnables to the thread pool for each slice, what if we wrap that runnable to start the profile for that slice? And then maybe all of those can probably come up.
Yeah, so we technically will have to duplicate the search method within the profile index searcher as well. So yeah. I think it's just like more we duplicate, more work it is to maintain, right? So
because I think the next problem would be virtual threads with Java 25, like you said. They would even.
No, sorry, you were asking.
Yeah, I thought you were looking at something. Okay. You said the overhead is something like 4x, 5x slower when you run it on the query profiler. Have you tried profiling the query profiler to figure out why it's that slow? Why is it so much cost?
I mean, at least to me, it seems that it is like, because the only overhead it is adding is those profiler.start, timer.start and timer.end. So yeah, maybe. Although actually that reminds me of a very interesting point. So it does like some approximation, like it doesn't act, because for example sometimes we are iterating over millions of documents. In those cases what it will do, it does some sort of sampling, right? So it will record like first 240 actual next doc calls. After that it will skip like 1/3 of those. After that it will skip 2/3 and so on, so that it keeps the overhead limited. But yeah, I mean, we can try doing that. We can run async profiler on a profile query and see what's going on.
That'd be fun.
I think this would be interesting because it's really, if you're spending most of your time in the profiler, it starts to call into question how accurate the profiling data actually is, right? At a certain point, maybe it's interfering with the execution of the query. I don't know.
That is true, and that's why, like, as I said, right, it is not representative of the actual query execution time. It helps you understand, how the query is executing, and like, what the query execution plan is, and like, for example, this clause compared to this clause is much more expensive in my query. So some
Counts are accurate.
Sorry.
The counts are accurate. The time.
The count methods are accurate. So like, okay, next doc was invoked these many times. So
yeah, and I mean, if the relative time is accurate, you might be willing to pay the cost. And I'd just be concerned that, I don't know, if you're spending a lot of time in the profiler, maybe it changes the execution profile of the slices in a way that it would be different otherwise, right? I don't know.
Did you look at any dynamic attaching of the profiler code to these points in Lucene instead of having actual classes do it?
No. So is your point about like a query is already executing and you attach to it?
Using something like a Java agent or something to be able to attach to the bytecode entry points, because for the most part you're not doing anything super complicated that you could potentially attach in and therefore not be changing the Lucene code.
Got it. Yeah. Maybe I'll talk with Ankit. He is our in-house expert on Java agent related stuff. So
I mean, how does a regular profiler work? Could you, I don't know, restrict it to only certain methods or something? I don't really know.
Sorry, what do you mean by regular profiler?
I mean, I'm just wondering if there's a way to do sampling profiling of Lucene specific, query information. I know, like the, don't know, if you could somehow tickle the method names, you know, that are on the stack, maybe the sampling profiler would just give you the same information. You know, the problem now is that every call to next doc looks the same. You can't tell which query it's part of, right?
Yeah.
But if you could somehow,
No, we can tell which query it is part of.
well, you can with your profiler.
Oh, yeah.
But if you use a sampling profiler like JFR, then you can't really.
Yeah, yeah, that's true.
There's some stuff
Right.
for like async profiler you can actually add in your code to add like a trace ID.
Yeah, I
and
think
stuff
so. It's
that
like
pop
booting
up, so that
X
might
off,
be-
replace the X on that next.
We'll have to use Java instrumentation
Jeopardy.
to start and end timers, similar to like how
Tell me which part of the query it is.
mock your classes.
Yeah, 15
But,
seconds.
I think the idea with this was that we want to limit to the interfaces that Lucene gives, so that we can know, like, to even if the code has changed, let's say some method got renamed or changed, so then how do we compare between versions? So it's like, okay, the schooler is taking time on next one. Probably that was the idea. But yeah, what you're saying.
Yeah.
Yeah, it was very insightful, at least for me. And since I think this question is not just to you, but in general, like there are a bunch of Lucene committees here. I think I'm just picking back on his question around open telemetry integration. And I felt like I was also recently working on OpenSearch and Lucene, and I was adding timers manually and building dashboards and visualizing on Grafana. And my question is around what it takes to integrate this thing to Lucene. Like for example, you were showing the profiler timers and other classes. I think they are part of Lucene itself, inbuilt in Lucene.
Yeah, those
so
classes
can we
are part of
replace it with like open telemetry, metric framework, or
With
maybe
the agent, right? Even without touching Lucene, you know what to modify. Well, with the OpenTelemetry agent, you can actually, if you know the fully qualified name of exactly what class you want to instrument, then it can auto instrument on the fly at runtime. If you're running it in this mode, it would get you all the time though. It wouldn't give you the ability to sometimes do this profiling and sometimes disable it. Because I'm sure that's a part of the feature here. We don't want every query. You want to be able to selectively, you know.
Yeah.
And also, I think in open telemetry, at least if I understand correctly, it will not do per query. It will do instrumentation in general for that class.
That's what I'm saying. Yes,
Yeah.
that's limitation.
Yeah.
But like using traces, we can also track individual queries. We have some trace ID or something, right? So I think both are possible. Maybe we have to revisit all of this and see how we can. And then all the things which we are talking about around sampling and all, I think that would be taken care by telemetry.
We could run a separate process that only does profiling. You know, send your production traffic to the main process, send the debug traffic. To
I mean, it needs the data duplicated because if someone
Yeah, right. True.
I mean, Lucene can take a query collector and a listener, or probably a list of listeners, and one of the listeners could be a profiler, one could be the open telemetry, maybe. But yeah, it will have to like get deeply integrated into.
I'm thinking like there are two ways to go about it. One is at a higher level where you say, okay, I want to use open telemetry, and one could be at a very lower layer when we are actually, recording those timers start and end. That is where you plug in open telemetry and say, okay, this timer is recorded using open telemetry and gets flushed to that system. So I'm thinking like maybe it might be a bit easier to do it at a lower layer than trying to change a lot of things in profiling and trying to plug it in at the top level. So, but I don't have like that much idea. Maybe we can chat.
I do wish that tree, the top level, I do wish there was an interface though, because then I could supply my open telemetry, blah blah blah, whatever, and someone else can do whatever they want to do. Right? It's awkward to be forced to use that and then to have a bunch of data, and then push it to open. That's not how to normally work with open telemetry.
I think one of the challenges with profiling has been, as I was asking it initially, right? Not many people are aware of it, and I think in that package there are only 2 commits. The one I listed over here. So, and that's why I think it's important. Like now all of you are aware of this feature, so I want to like collaborate and so that we can improve this.
Thank you for that.
Cool. Yeah.
Thank you.